This is Module 12. We're going to do the first few problems in Exploration 10.2. The problem reads as follows. In 1970, the U.S. Selective Service conducted a lottery to decide which young men would be drafted. Each of the 366 birthdays in a year, that includes people who were born on those leap years, February 29th, everybody was assigned a draft number. Young men born on days assigned low draft numbers were drafted. And if you were assigned a high draft number, it was unlikely you were drafted. So you didn't want to get a draft number like 1, 2, 3. You definitely wanted to get a draft number like 365 or 366. So we're going to regard the 366 dates of the year as observational units, and we consider the two variables that we record on each date. We record a draft number and the sequential date. So, for example, January 1st is called number 1. January 2nd is called number 2. By the time you get up to January 31st, you're at birth date number 31, and February 1st would be birth date number 32, all the way down to December 31st, which would be 366. Then they take each of those birth date numbers and assign them randomly to a draft number, 1 through 366. So, problem number 1 asked if it was a perfectly fair random lottery, what should the value of the correlation coefficient be between draft number and the sequential date of the birthday? And it should be 0. It should be the case that when you assign these birth date numbers 1 through 366 to the draft numbers 1 through 366, you get completely random dots. Absolutely no linear pattern whatsoever. Remember, if there were some sort of linear pattern, that would be bad. So, for example, if it had looked like a linear pattern like this, that would mean people who were born like January 1st had a high draft number, and people who were born down here with birth date 366, which is people born December 31st, would have a low draft number. And that wouldn't be fair. That would mean all the people in December were the people who would get called up to be drafted, and the people in January would be very unlikely to be drafted. Similarly, it would be unfair if it were a line that was increasing, because then the people in January would be likely to be drafted and the people in December would be unlikely to be drafted. Either one of those would be bad, would be unfair, would not be random. We want it to be completely random scattered dots with correlation coefficient 0 or very close to 0. Okay, so this figure below, Figure 10.6, shows the actual scatter plot for the 1970 draft that occurred. So you see it looks pretty random, right? It looks like a bunch of scattered dots. There are 366 dots there. So it says, let's take a look at that scatter plot. Does the scatter plot reveal much of an association between draft number and sequential date? No, it looks like a random scatter plot. I certainly don't see any linear pattern there. So 2b, based on the scatter plot, can you guess the correlation coefficient? I would guess R equals about 0. Notice I'm using R, not rho. This is a sample correlation coefficient. This is a sample of the draft that occurred in 1970. They also did drafts in other years. The population correlation coefficient would be all the possible draft lotteries that would exist. So does it appear that this was a fair random lottery? Yes. Appears fair and random. It doesn't look like, for example, the people in January would be called up more likely, or the people in December would be called up more likely. So it's difficult to see much of a pattern or an association in this scatter plot, so it seems reasonable to conclude that this was a fair random lottery with a correlation coefficient near 0. But let's dig a little deeper. Problem 3. It says the 1970 draft lottery data sheet, which is at the end of the exploration, shows the draft number assigned to each of the 366 birthdays. It asks to find your own draft number assigned to your own birthday. So I'm going to go down to that. Okay, so this is the table that shows in 1970 how the birth dates were assigned to draft numbers. So for example, to read this chart, you find your birth month. So my birth month, for example, is May. And then you find the day of your birthday in that month. So let's say, for example, mine was May 8th. So I go down the May column until I find May 8th, my draft number would be 321. If your birthday was September 13th, you would go down the September column to 13 and you'd find your draft number would be 175. So you find your draft number. This was the actual draft number assignments for 1970. Okay, then part B says, is your draft number in the bottom third, middle third, or top third? Well, mine would be in the top third. That depends on your birthday. So that means I'm in the last third of the people to be drafted. Problem 4 then says there's actually a second table at the end of the exploration, which has ordered the draft numbers within each month. Now, let me go down to that and kind of explain what that shows. Okay, so this is a different table and it's giving the rank. So, for example, let's just focus in on January and try to understand what we're seeing. So, there's 31 days in January. So, what this 17 is saying is, in January, there's some birth date that was assigned draft number 17. And that is the lowest draft number assigned to anybody with a birthday in January. And if you go down that column further, it shows that the highest draft number assigned to anyone with a birthday in January was 355. And then it puts them all in order in that respect. So the lowest draft number for anybody with a birthday in January was 17. The highest was 355. If you go over here to October, and you consider all the draft numbers assigned to people with birthdays in October, it looks like 5 was the lowest draft number assigned to anyone who has a birthday in October. Okay, so it's basically just like honing in on every month individually and taking the draft numbers assigned to the month and ordering them, like lowest draft number assigned to people with that month up to highest in that month. Okay, so my birthday number was in May, and apparently of all the people who have a birthday in May, the lowest draft number to people born in May was 31. Okay, so what it asks us to do in problem 4 is to find the median draft number for your birth month. And then we're actually in part B going to find the median draft number for all the different months. So we're saying find the draft number such that half of the draft numbers are above it and half the draft numbers are below it. So you could go down to this chart and find the draft number for each month so that half the draft numbers are above it, half are below it, because it's already put in order for each month for us. So I'm going to just actually give us the answers for that rather than, spending the time walking through finding all those. Okay, there they are. And let's just make sense out of this a little bit. So this number 211 for January, it means half the people who have January birthday had a draft number below 211, and half the people had a draft number above 211. For June, half the people with a June birthday had a draft number below 207.5 and half were above 207.5. And if you get down here to like December, half the people with a December birthday had a draft number lower than 100 and half had a draft number higher than 100. Remember, you don't want a low draft number. If you get a low draft number, you're getting called up. If you have a high draft number, it's very unlikely you're getting called up. So part C asks, do you see any pattern or trend in these draft numbers? What I'm seeing is up here in January, February, March, April, all these medians are above 200. By the time you get down here to these later months of the year, notice that the medians are lower. It seems like as the months go later and later, the draft numbers are getting lower. Okay, so this was just kind of one quick glance at maybe a trend that could be happening. But remember, we said that we saw a scatter plot matching up birth dates and draft numbers, and it looked completely random. But this is kind of saying, well, maybe it isn't quite so random because people who have these later birth months maybe are having lower draft numbers. So which is true? How do we figure it out? So number 5 says the correlation coefficient for that full data set, for that scatter plot that we saw above, is R equals negative 0.226. What does this number reveal? Is it consistent with the scatter plot? Okay, so I mean, R equals negative 0.226. That's pretty close to 0. A correlation coefficient like negative 0.226 maybe seems like close enough to 0 to tell us that, yeah, it is random. That's just a normal sort of correlation coefficient you would expect to get. It's close enough to 0 that we would say it's random, but we're not really sure. We have to look at that distribution of sample statistics that would be centered at the population correlation coefficient of 0 and see how spread out it is. I'm wondering, is R equal negative 0.226 in this realm of normal, usual, expected sample statistics to get if the population correlation coefficient is 0, or is R equal negative 0.226 unusually low? Is it down here in the tail, giving us enough evidence to say that it looks like there is correlation? So we're going to need to do a test of significance for this using the simulator. See the next video to see that happen.